Our last unit for the year is called Polar Equations. I think you graphed them last year in Honors Pre-Calc. In polar equations, something like r is equal to sine of theta. We don't have x's and y's, we have r's and we have theta. You can change your calculator, change your mode to polar mode, and when you go to y equals, you'll see that it says r equals. We always want to be in radian mode. So when we're in polar mode, we have an r and we have a theta. Theta is the angle. Theta is the angle. We go counterclockwise from the positive x-axis, so theta is your angle that way, and r is it's called the directed distance. Directed distance, because it can be positive or it can be negative. And it's from the pole, and if it's positive, it goes towards your angle, and if it's negative, it goes away from your angle. So let me give you an example of how to graph this. Let's say my r theta is, let's go with 3, and my angle is pi over 4. So from my positive x-axis, I'm going pi over 4 units counterclockwise, so I'm halfway up because you know that's pi over 2. So I'm halfway here, and my r is 3. That means the length of this segment that I draw here is 3 units long. Okay, this right here is my angle. It's pi over 4, 45 degrees, pi over 4, and it's 3 units long. Okay, on the same graph, if I asked you to graph -3 comma pi over 4, okay, my angle is still positive, so I'm coming up this many units, but I'm not going 3 units that way. I want to go 3 units backwards across the pole, and it would be down here. And it would be down here somewhere. And this would be my -3 comma pi over 4. Okay, if I give you a point to plot, there's only one way that you can plot it. But if I put a point up here, you can name it several different ways. Okay, so the point, let me get rid of this one here, that we have there is my 3 comma pi over 4. Okay, we could have gone this way. And if we go this way, my angle is -7 pi over 4, but my directed distance is still 3. These two pieces right here give me the same point. Okay, I can do one more. I can go 5 pi over 4, and my r is -3. So now I'm going to here, 5 pi over 4 here. Instead of going 3 units this way, I go 3 units back across the pole. And all 3 of these actually get me the same point. Okay, so there are many different ways that you can name the same point. Let me try to go through some examples here. I know it's not easy, I'm sorry. So let's say I have, let me graph a point. And my point is right here. And the coordinates of that point, let's say, are 1 pi over 4. So that means my angle here is pi over 4, and this distance right here is equal to 1. 2 things that you need to know, it's a conversion. This is called polar. When we graph x, y, that's called Cartesian. So x, you need to know, is equal to r times cosine of theta, and y is equal to r times sine of theta. This is a big deal right here. This you need to know. So if I want to change at this point from polar to Cartesian, I do a little bit of substitution. So my x value would be, my r is 1. My cos of pi over 4 is rad 2 halves. So my x value is rad 2 over 2. My y value, I'm going to do the same thing. I put a 1 in place of r. I put a pi over 4 in place of theta. The sine of pi over 4 is also rad 2 over 2. So if I name this particular point right here in polar mode, it's 1 comma pi over 4. On the regular xy axis, rad 2 halves, rad 2 halves. So think about this. If your x coordinate is rad 2 halves, that means that this distance is rad 2 halves. And if your y coordinate is rad 2 halves, it means that you went up rad 2 halves. Okay, if you do the Pythagorean theorem here, you'll see that your hypotenuse has a length of 1, which we know it does because that's what our r value is. Okay, so let me give you some more examples. If I tell you, for example, that r sine theta is equal to 3, and I would like for you to change that into rectangular, r sine of theta is just y. So this is really y is equal to 3. What you can do in the calculator now, go into polar mode, go into y equals. And when you're in y equals, it will say, for example, r1 equals. If we put this in the form r equals, we get 3 over sine theta. And if you graph 3 over sine theta, you're going to see a horizontal line, which we know is the line y is equal to 3. When you go into your window, when you're in polar mode, you'll have a theta min, a theta max, a theta step. Normally, your min is 0, your max is 2 pi, and your theta step, again, is around 0.13. You have an x min, an x max, a y min, or y max. That you can play with the window, but we also have to adjust what our value for theta is. Okay, I think last year you graphed the pretty polar rows, so we'll get to those shortly. I'd like you to go to y equals, which is really r equals, and you get r is equal to 1 minus sine of theta. When you hit graph, I would like for you to watch it graph, not just look to see what the final answer is, and I'll try to explain some things to you. It looks something like this. Don't laugh at my picture, please. I know it's not good. Something like this. Kind of, sort of, something like that. I don't know. Looks like a peach to me. I'm not sure. So when we're going, theta is 0 to 2 pi. So think about what happens. When you graphed it, you started right here. That was the initial point. And the reason for that is when theta is equal to 0, which is your theta min, and you put a 0 here, the sign of 0 is 0. So you're getting r is equal to 1. So when I'm at an angle of 0, my y value is 1. Okay, if we try, for example, theta is equal to pi over 2, the sine of pi over 2 is 1, and my r value is 0. So when I get to my positive y-axis here, it swings back around to there. Okay, and that's why it looks like it does. You have to play with the window a little bit. Let your theta min be 0, let your theta max be pi over 2. Try it again. Let your theta min be 0, let your theta max be pi. See if you get the full picture. If not, make the window bigger. If you go 0 to 4 pi, you're going to get the same picture. And if you watch, it goes around it 2 times. We say it traverses the picture twice. We don't want that. We need it to traverse the picture only once. Okay, if you want to see something pretty in your calculator, graph the following. R is equal to cosine of 2 theta. And you'll get the polar rows. It's a nice, pretty picture. Okay, so one more thing that we're going to do with polar equations, and then we're done. Finding area. Of course, we can find area for anything. So there are 2 ways that we're going to do this, and it all depends on what I'm asking you. So if I ask you to find the area between the origin and the curve, between origin and curve, you're doing this. The area is equal to 1/2 from A to B. These are your theta values, usually 0 to 2 pi, and it's r squared d theta. And that will get you the area. So let's go back to the picture that we had and I erased. We have r is equal to 1 minus sine of theta. And I get to draw that picture one more time. Something like this. And I can ask you to find the area. This entire area right in here is what I would be asking you to find. So since we needed 0 to 2 pi to graph the entire picture, you're going 1/2 from 0 to 2 pi. You already have that in your calculator. 1 minus sine of theta squared d theta. Just keep in mind you have it saved as R1. So you can do a Math 9, put your bounds, and when you're here, it's vars, y vars, but don't click on function, don't click on parametric, click on polar, and highlight R1. It will insert it right there for you. And when you do that, the area inside that is 9.425. Is what that area is. Okay. One more thing that we can possibly do is we can find the area between two different polar equations. Let me just get rid of that. I need the whole board. Between two polar curves. And I have to specify that it's inside of one and outside of another, or it's an overlap by both of them, etc. So let's try r is equal to 1, and r is equal to 1 minus cosine of theta. So put those both in your calculator, please, and graph them. And here we go. R is equal to 1 is really just a circle with a radius of 1. So what I'm trying to draw here is a circle. I'm telling you that because it probably doesn't look like a circle. And 1 minus cosine of theta is, it comes in here, that doesn't work. It comes in here and then out here. And point of intersection is right here, pi over 2, 3 pi over 2. So if I ask you to find the area, and I'm going to give you two separate questions here. Inside r is equal to 1. I think I got that wrong. Nope, I'm sorry, outside, my mistake. Outside r is equal to 1. And inside r is equal to 1 minus cosine of theta. Okay, you have to play with your window, and it looks like the point of intersection is pi over 2 and 3 pi over 2. Keep in mind we can have negative angles. So we can have pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2.